Hello everyone, let's wait for some time for everyone to join, at least a couple more, then we'll start the session. Yeah. Hello everyone. So we'll start with the tutorial series of week 3 of the course. So before starting the tutorial, like if anyone has any doubt in the assignments or any previous weeks videos, they may start asking the doubt or putting in the chat. Yeah. Got a chat. In assignment to question 6. So see, I'll not be solving the assignments. I can't solve the assignments. It's uh okay. Assignment 2, right? Assignment, where is the chat? Please tell me sliding on the protocol. Okay. Uh, in assignment 2, question 6. The assignment 2 solution is released. I can discuss the question 6. Okay, so I'll just give me a second. I'll just share my this screen and
అడగదు.
yeah, so let's discuss. I just wanted to turn on my tablet so that I can discuss easily. Give me 1 second. Okay. Yeah. So
ఫుల్ 150 అంట అక్క. ఫుల్ 150 అంట, హాఫ్ 100 అంట. నీ ఇష్టం అక్క. మనం గట్టి తింటే కూర్చొని కింద మీద పడి తింటే హాఫ్ ఫుల్ తింటా, లేదంటే తిన్నా.
okay. So I'll just create a new. Okay. Okay, so we'll go to week 2, question number 6. So in the if my page is visible. Okay, so so it's saying that अरे
हाँ?
please
मम्मी
unmute yourself.
जरा मैगी ಮಾಡ್ಕೊ ರೊಟ್ಟಿ ಮಾಡೋಣ ನೋಡಿ ಅವನಿಗೆ ಒಂದ್ರ ಮ್ಯಾಗಿ ಮಾಡ್ಕೊ ಒಂದ್ ಸ್ವಲ್ಪ ಮಕ್ಕತ್ತೀನಿ ಏನ್ ನಿದ್ದೆ ಹೊಂಟಿತಪ್ಪ
It's saying that yeah, it's saying that there is a client and a server. So there is a client and a server, and so this is the mail server, and this is the mail client. Okay, so it's saying that first operation is sending an email from mail client to mail server. So this mail client to mail server email sending. Okay, and the second is downloading an email from mailwork server to mail client. So mailwork server is here. So I'm downloading the email again. Downloading an email from mail server to mail client. Then checking email in the web browser. So mail client is your PC and mail server is a Gmail's server. So and you are downloading this email and email and you are then viewing it in your PC. This is your PC on your browser, right? Checking email on your web browser. Let's say this is Chrome. So it's asking like what are the application level protocols used in these three of activities. So it's so first thing is that web browsing. So so last time we were teaching the HTTP protocol. So website like your web browser and all the websites use two protocols, HTTP or HTTPS. So when you are using your web browser to see a email, you're sort of requesting it through HTTP. Okay, so the options. So the third one will be HTTP or HTTPS. Okay, and the first one is when you send email from mail client to mail server, the protocol that is used is SMTP. So this one is SMTP. SMTP. Okay. So by looking at these two options for A and C, for 1 and 3, so you can say that there are two options, option B and C. Option B have SMTP in the first as the first guess, and HTTP as the last guess, and so is the option C. But if you look at the second operation, that is downloading an email from mail server to mail client, the protocol that is involved here is POP, or that is called post office protocol. So there are two protocols involved in downloading the email from the server. That is one is POP and one is IMAP. But since there is no IMAP here, so you have to assume that it is POP. Why it is not FTP? Because FTP is used to transfer file over the internet. So since since we're just downloading the email, not the files, so the protocol will be POP. If there was any file involved, then the protocol would have been the FTP. Okay, so C is the answer. Then coming to the chat, assignment 2, question number 8. Assignment week 2, assignment 2. Then another is assignment 2, question 2. Assignment 2, question 2 and question 8. Uh, so question 2. TFTP is failed. Oh, okay. So question number 2, someone asked question number 2. Question number 2 is pretty straightforward. Like TFTP is an independent file transfer protocol. It is not built upon anything. Let me show you. Let me show you that. Yeah. So TFTP stands for trivial file transfer protocol. So here is application layer, and here is FTP, HTTP. All these protocols are there. Similarly, there is TFTP. So it is relying on the transport layer, and transport layer has TCP and UDP. This TFTP is relying on UDP, and it is going down. So it is relying on UDP, which is a transport layer protocol, but it is not relying on anything else. That's why, like, it's it's not top of anyone, any protocols. Yeah. So okay, so then we can move to the okay. So this is the answer of question number 2. Then we can move to the question number 8 of assignment 2. Yeah, where's the question number 8 here? Yeah. Okay, so the question number 8 is consider the following statement and choose the correct option in correct option like SNMP v3 ensures a message cannot be read by an unauthorized entity. SNMP v3 cannot ensure the validity of source from where the message is sent. Options are only I is correct, option D is only second is correct, both is correct, none of the statement is correct. So SNMP V3, what it does is that it yes, what it does is that it so uh, so there is a sender and here is a receiver. Okay, the sender is sending some data to our receiver. So when the sender is sending a packet with some data, it is calculating the hash of this data and sending this hash with it as well. So the statement that's saying like the ensure the message cannot be read by an unauthorized entity. I think so. This doesn't provide that. Uh, Let me see. P- P- Let me see that. So the second statement is partially correct. So it actually I can say it validates uh, the basic SMTP like doesn't guarantee the source validation by default. It offers the mechanism that address the security concern. It's not exactly like it doesn't guarantee. So SMTP what is like it so if you implement it correctly with appropriate security measures, this allows validity of source. So it's the question. So the question is that um, his question is that does the SNMP v3 protocol validates sender or receiver? Like if a message is going to the receiver, does it know is it coming from its valid sender, or it's asking like when you're sending a message, do you know it is not it cannot be read by an unauthorized reader? But here I think the SNMP v3 ensures that it cannot be read by an unauthorized entity, because SNMP, when properly implemented and configured, can ensure that a message cannot be read by an unauthorized entity. So what it does is that it encrypts the message, okay, and for the integrity of the message, it uses hash or MD5, some message digest algorithm. uh, I mean, it doesn't directly prevent reading the message content. It guarantees that unauthorized modification will be detected in rendering the message usable, um, uh, message unusable, and alerting the recipient. Okay, so I think the answer to this question is questionable, because option one is correct, option two is not entirely correct, like it's partially correct, but the answer says that option two is correct. So yeah, I think we might take this up with admin people to make it correct. So okay, so I'll just briefly say, like, what I said verbally. So if there is a message, hi, the code is, like, let's say you are communicating and there is secret code, and the code is and you are sharing the code of your house to someone. The code is, let's say, 4257. Okay, and this is a message. Okay, so and you are a sender and you are sending it to the receiver. So what this does is that it first encrypt it. Okay, it first encrypt it. When you encrypt the message, it will come something like, this, something random. Okay, something random is there. When you send this thing over the internet to the receiver, there might be a middleman who can intercept this message and try to read that. Okay, okay. Since this thing is encrypted, this man will not be able to read this. Okay, this man will not be able to read this. Okay, so this verifies the first statement. It ensures that the message cannot be read by an unauthorized entity. Okay, and then comes the second. Then comes the second. Yeah, then comes the second thing, that is, like, how to know if it is modified by someone. So it can read this encrypted thing, and okay, it can read, but it cannot comprehend or cannot get anything out of this message. Okay, but what else can it do? So this middleman can take the packet from here, open the packet, then add some random bits or random information, or it can change the code from 4257 to 1234. Okay, and then send the packet again. It's very hard to change the code since it is encrypted. Maybe it can predict that the code is getting shared, it just add some bits or something. It can send the packet and the receiver will receive a wrong packet here, rubbish packet. Okay, so to prevent that, what senders do is that so let's say this is an encrypted version of the message. Okay, along with that, you pass this message to a hash function. So what hash function do is that it squeezes the message into a 64 or 32 byte number. So you can attach this number here. Okay, and then send this. So what will happen, even if there is a middleman listening to a conversation, it adds some bits to your already defined data. The hash will be, so already defined data here, like, when and send it. The receiver side, receiver will take this mixed data and calculate the hash of it. Okay, then it will match this hash with the hash that they got. Okay, if it is not equals to the hash that has already got, it will reject the packet. Okay, they reject the packet and say that this packet has been compromised, so that's why I'll not accept this packet, and so hence the communication will be broken. So it also, like, ensures that the since this source is there, so So now here the message source was the sender. Okay, but here, since there is someone else is modifying the packet and sending it, this receiver is able to comprehend that, okay, this is not from the source that I am expecting. So it does verify the source from which the message is sent. But this thing is not by default. So if you set it, it can ensure. But if you do not set it, it cannot ensure the same thing. So uh, so yeah, so it's a bit controversial. So the answer is given as B. So if this is a incorrect answer, I think if you appeal in the discussion forum, they might give grace mark to everyone on that question. So yeah, so this is the admin thing to um, take care. Okay, so I think everyone doubt is resolved. We can move to week 3's content. Okay, so transport layer things. Transport layer. So what happens is that, so as I said last time, that there is your applications. There are many applications. Let's say you are opening Google Maps. Okay, so Google Map is the application, and when you are opening a Google Map application, so let's say you want to see the map of India. Okay, so googlemap.com.india. Okay, you're trying to see the map of India. So this is a request, right? So when you want to see the map of India, it's a request. So let me, uh, okay. So you want to see the map of India. So when you go to the Google Maps page and there's a box, okay, and you put India here and you hit enter. Okay, so it will request your page to the internet. Sorry, Google server. Okay, and you will get back the response, and it will be in a page. It will be shown that there is India map. Okay, not a very good one. But, okay. Yeah, and some other things there. Okay. So what I'm trying to say is that, so this journey is not direct. Okay, this journey is not direct. So what happens is that it goes through a lot of layers and goes through different networks over the sea. Then it goes to the server, and from server, similarly, you get the response and get it here. So how it happens? Okay, so when you're trying to ask for Google Maps, so this request is a get request. You are requesting for something. I can show you if I can show you developer tabs. Chrome. Uh, yeah. Yeah, it's a GET request. Okay, so it's a GET request. So you put a GET request here, and so by putting the GET request, the protocol you use just HTTP. Okay. So there are different layers here. Okay, as I said earlier, there is application layer, then network transport layer, network layer, data link layer, and then finally physical layer. Okay, so each layer has a different protocol. So when you are placing the order that give me this Google Map page of India, what you're trying to do is that you're trying to create a query in the application layer. Okay, you're not querying in any layer, you're trying creating a query in the application layer. So when you're doing the application layer queries, what you need to do is that you need to follow some protocol. Which layer you are, you have to follow the protocol of that layer. Okay. So here is the application layer protocol HTTP that is followed when you're browsing something in the internet. It is the browsing, so HTTP is followed, and HTTP has several what is it called, request methods. One is get, one is put, one is post, and so on. Okay, then we are using get method. We want to get something. We want to get the map of India, so we are just querying with India as the query. Okay, so when you're doing that, so you have a query, that is the data. Okay, we have the query, and when you are querying, you are putting a HTTP header or the application layer header. Okay, and since this is a HTTP request, this will be your HTTP header. Okay, this will be your HTTP header. Okay, this is the data where the request is live, and you are putting a HTTP header and passing it. Okay. So when you pass your data to the subsequent layer, okay, so this is application layer, and application layer you have some request and the HTTP header. Okay, you pass that, like, you just cannot throw the data from the browser. It has to go through the computer, right? So next layer in the computer comes the transport layer. So what is transport layer? Transport layer, like, it's sort of virtual layer, and so it ensures the smooth transition of segments between two endpoints. What happens is that, so if there is a system, okay, there is a system, there are a lot of applications running in this system. Okay, because, like, there is your Chrome, there is your some background application, there is your mail, there is your um, WhatsApp is running on WhatsApp desktop method, your GitHub is running, your code is running, some a lot of methods. Okay, and all of this requires internet, and when all of this requires internet, and this is your computer, and you have opened all these things simultaneously, so it has to go through certain channels. Okay, certain channels, and all these things will go to the internet or the server. Okay, you got that? Okay, so let's say here is your Chrome. Okay, here is your Chrome, and your map request came from Chrome and went through this channel to the internet. Okay, and you have some WhatsApp is running with this server, and you have some other page opened for the WhatsApp, and the request or message from WhatsApp is going through this channel. Okay, we just talk about one channel, like, your this channel. So this channel are called ports. So each application in your device is running in some ports. Okay, I can, so actually there is a command. Uh, so which application is running on which port? CMD. Yeah, the command is this. Yeah, so this will show the which application is running in which channel. Okay. So you found the channel where the application is running. Okay. And you found the channel where the application is running, and you want to okay, so there is a channel where the application is running, and there is defined by the port number. Okay. So okay. So basically, so this port number, along with port number, there are a lot of other things as well. Okay. Because when a pack, a data packet or anything comes here to this level, the computer, now the work of this transport layer is to decide which channel to which channel to send this packet to. Okay. To which channel I should send this packet? Should I send this? So if you are getting a reply from your map, Google Maps server, you cannot send this to your uh, WhatsApp server, right? So sorry, WhatsApp channel. You have to send this to your this channel to the Chrome. That's why that in the transport layer manage that, like which thing will goes to which application. So this transport layer, there are several protocols as well, and all these protocols. When there is protocol, there is header. So what is header basically is like it's specifying which protocols which I mean in the protocol there will be several rules like this should be this should be this. So in the header we specify all these things like which application is go which application to go to, which process is calling it from the top layer. So when this packet is goes to the transport layer here to the channel, it first attach it here is your HTTP header. Along with that, you put a TCP header. This will ensure that this channel was used while communicating the data. So when you return when you get a response from the Gmail server with this channel as your destination, please send it to this channel, and I will so that I will publish it in the Chrome. That's how HTTP header comes into play, where HTTP header is attached to the data. Okay. So this is the transport layer thing. So now consider this point. Okay. Consider this point. Let's say this point, and let's combine all these things to one single triple arrow, and this is your PC. Okay. If you get your packet here or any response here, you can decide which channel to go by looking at the where TCP header. Okay. But what if the packet is here or your response is here, and from here is one PC, here is another PC, there is another PC. Okay, so there are several PCs now. Okay, so what to do? You have to look for now. So now you have to look for which IP. Okay, and which IP to go to will be specified by the next layer, the network layer. And if what it does is that it puts another header. So this is HTTP header or application layer header. This is TCP header, and it puts another header that is network layer header or IP header. Similarly, there is another layer that is DLL layer, and DLL layer. So it will put. So this is till network layer. It puts DLL layer header. Okay, and there is physical layer as well. That was physical layer header. Okay, so this is the whole story behind it. But since we are learning about transport layer, let's just focus on the transport layer first. Okay. So in transport layer, what you saw is that there is different channels, and different channels is provided by different ports. So HTTP. So if you are making an HTTP request or HTTPS, let me see what is the port number of HTTPS. HTTPS number. Yeah. Okay. So if you're if you're using this as HTTP request, the port will be uses 80. I mean, if it is the HTTP, it is the PC, and you are trying to open a do a HTTP request, it will go through channel 80. Okay. And if you're looking at HTTPS, it will go through 443. So there is another channel for HTTPS. Go through 443. Okay. So there are different. So these are default. Uh, these are default. These are default port numbers. Suppose you are using a internet service, and you are using a browser. Let's say when you are using a browser, all the browsers, all the websites that uses HTTP protocol, uh, that uses port 80. But if you are, let's say, you are making another application, okay, that is not a web page, that is something else, and that requires your internet. Then when you are using that, you can assign another port to your service. Okay, but there are some predefined port numbers for some of the service, and you cannot take that port number. That will be used for that service only. Okay. So, so the HTTP uses port 80. So HTTP uses port 80. So when you so you have to specify that port 80 is used. Okay. So apart from that, so once you mention all these things and pass it to the transport layer will attach a header. Okay. So transport layer will attach the header and send the packet. Okay. So before sending the packet, so then since you are making an initial connection to the to your what to your server, so before sending the packet, what TCP does is that, so there are two protocols in transport layer. One is TCP and one is UDP. So since you are passing through TCP, when we come to the TCP transport layer, okay, when you come to the transport layer saying that, okay, this is my request, I want to send this, but I want to send this to Google server, and but this is my request, and this is my header. So what transport layer do is that it will put TCP header first, okay, and it will see that what is the destination address, okay. If the destination address is something it has already dealt with, the connection is already made, then it will send the packet. Otherwise, what it will do is that it will first establish a connection, then it will send the packet, send data, and communicate. And three, it will close the connection. Okay. There are three things: connection establishment, communication, and the connection. Uh, what do you say? Connection. Yeah, closing the connection or connection breaking. Okay. This is the role of TCP. What is the role of UDP? UDP doesn't actually do the connection establishment. It just send the packet. It doesn't actually care if the packet is lost. It just send the packet. Okay. So if you see in the real life, if when you start using a HD service, like when you open YouTube and start streaming HD videos, then like more than 720 pixel videos. First, so that uses your TCP. So this 720 pixel video is TCP, and when TCP ensures the connection is established and the packets are flowing continuously, when it ensures that, then only you get all the HD videos, like all the clarity. When you reduce the resolution to, let's say, 720, sorry, 480 or 360 pixel, it uses the connection of UDP. That's why even if some packets are lost, it will not send it again. That's why you get the overall bad quality video, but the speed is very fast. You know why? Even if some packets are dropped here in the middle, it will not care. It will send the next packet. But here in the TCP, if some packets are dropped, so the sender will send it again. So since on regular basis there are some packet dropped in between, it will resend all those packets, and it will take time. TCP takes time in all these things. That's why TCP is a very slow protocol and UDP is a very fast protocol. Okay, that's the difference between TCP and UDP. TCP is a connectionless, so the connection. Sorry, UDP is a connectionless protocol and TCP is a connection full protocol. Not connection full. The correct term is, let me search it. Connection oriented protocol. Okay, and UDP is a connectionless protocol. Okay, so that clears out TCP and UDP. But then let's come to the part where we use TCP for connection establishment. So our story was here, like TCP sees that okay, there is a new request. So what it will do is that it will first establish a connection. So here is your client, and here is the server, or you can say here is your sender, and here is the receiver. Okay. And TCP is a dual band protocol. Oh, sorry, duplex. That means sender can send data, the receiver can also send data. The data can flow from each direction. Then only when you request for India map, you are sending the query India as a data, and you're getting the map as a response. Okay. So first is connection establishment. In the connection establishment phase, first the sender need to send a receiver saying that this is a invitation for connection establishment. Okay, so to send that, first let me open the sheet for me, and like I need to take reference. Okay, so so there are first two flags. So if you look into the TCP header has two flags. So there are a lot of okay. So there are so what I say, each protocol has a header to it. Okay, so each protocol means rules. So which rule is followed is mentioned in the how what rule to follow is mentioned in the header. So in the TCP header there are two flags. One is SYN flag, one is ACK flag. Okay. SYN flag is the synchronization flag, ACK flag is the acknowledgement flag. So SYN flag is used to synchronize between the communication. Okay. So when you are sending the first packet, so you got your what the hell is happening? You got your response from sorry, you got your message from application layer that you need map of India. Okay, and with some application layer header, and you want to attach a. So you pause here. Okay, what you do is that you pause here. You saw this packet and you pause here. What you send instead is a SYN packet, where so this is some data SYN packet, and this is the TCP header. In the TCP header, there are so many fields that it will be filled. There are like I think 20 byte field. Okay, so one of the bit is taken for SYN. So when you are making a connection, you put SYN flag as 1. SYN flag 1 means it is the first packet in the communication between these two parties. Okay, when you are sending the first packet, you set the SYN flag as 1. Then you send something that is called sequence number. This is the sequence number flag, sorry, synchronization flag. Then you send something that is called sequence number. So what is sequence number? Sequence number shows what is the sequence of data byte that has been passed to the receiver or the other side, and what is the next byte is expected from the sender. Okay, so then you may ask, if it's source, what is the data byte that is going to be communicated from the sender to the receiver? Why it is 521? It should be 0, right? Because it is the first byte I am sending, and this should be 0. But this is not true, because while sending the packet to the in the initial connection to the receiver, we need to mark that. But so this is the reference point from where the data sending will start. We can mark it with 0, but when you mark it with 0, what happens is that there are a lot of um, there is a lot of applications or lot of processes simultaneously starting the communication. That's why it will get a lot of SYN packet with sequence number as 0. It will get confused which one is which. That is problem number 1. The second problem is, if in any case the first packet is lost, then it will not be able to predict that what to do next. That's why what we do is that we generate a random number that is called IRSN. So it's called initial random number generator, or IE. Sorry. Uh, it's called RISN. Random initial sequence number generator. So it generates a random initial sequence number. Let's say it generated 521. You took the 521, you put it in the sequence number and send it. Along with that, what do you need to mention? You need to mention MSS. Let's say it is 1460. So what is MSS? MSS is the maximum segment size. Okay, maximum segment size, and there is window that is, let's say, this. What is maximum segment size? So you're saying, what is the maximum number of byte that I can accept in my end? So each device has a different this maximum range, and each network has a maximum range. So what it does is that it asks, like, what is the maximum number of this? So it sends what is the maximum data byte that you can send that I can process. So what if it sends a packet that is bigger than maximum size? It will be fragmented into smaller segments. Okay. So that is the case. It will be fragmented. The segment will be fragmented into smaller segments. Okay. So there is that, and yeah. Yeah, so that is the maximum size. What is the window size? So window size is the
size of the so there is always window size here. Like there is a window size here and there is a window size here. So when packet comes, it doesn't actually, like, there might be out of the sync packets, there might be packets coming late. So they always put it in the buffer and rearrange the packet after every packet is arrived, or like, after it got the packet that was expecting next. So in this type of scenario where the next packet is so it can accommodate only let's say 10 packets at a time, and its maximum packet size is 1460. The window size will be 1460 into 10, that is 14,600, and this is called window size advertisement. You're advertising your window to the sender, sorry, to the server or to the receiver, that this is my maximum window size and I cannot receive anything more than that. Okay. So yeah, so this is so this is one thing. Like let me put down one thing. Other stars, don't draw anything. I will be kicked out of the meeting. So there is window size. Then so okay, so that's why we maintain the window size. Then comes your like okay, so you first made your advertisement that like I'm just trying to make a connection to with you, and this is my sequence number I have fixed, and this is my maximum segment size, and this is the window size. Then comes the receiver. Receiver says this. Receiver sends a reply. In the reply, it has also RISN of 2000, let's say. Okay, so it will send the sequence of 2000. Okay, and the sin will be 1, because since it is a synchronization method, it will 1. And let's say its window size is, then let's say its maximum segment size is 500, and its window size is, that will be 10,000 bytes. Okay, it replied that okay, I also want to make the connection, and this is my things, like this is my sequence number, and this is my synchronization number, and this is my message, and this is my window size. And along with that, what else it will send is interesting. So along with that, it will send you'll set the ACK flag as 1. So there is a synchronization packet as well as an acknowledgement packet. When you set the ACK flag as 1, so this is 1, then you say this is called piggybacking. So this, you are sending a synchronization packet. So sender sends a synchronization packet first, then you are again sending the synchronization packet from your receiver end, because there is a duplex connection. Everyone will send the packet. Everyone will send the data. So since everyone is sending the data from one side to another, then what you do is that you synchronize first. Okay, you synchronize that. So synchronization is done. So also this receiver is sending a synchronization thing. Along with that, it's saying I am acknowledging the fact that I received your packet. So it is acknowledging this thing. Okay. That I received your synchronization message and I am ready to synchronize. And along with that, it sends another thing, that is the acknowledgement. In the acknowledgement, it mentions what is the next byte it expecting. So it yeah, it it mentions what is the next byte it is expecting. So since I started with 521, the SYN packet take 1 byte. Okay, so I'll just write 4 things. The SYN packet here take 1 byte or 1 sequence number. Acknowledge IACK. Sorry, I'll just when SYN is equals to 1, it take 1 sequence number. When ACK equals to 1, it takes 1 sequence number. When ACK equals to 1, sorry, let's check. 0 sequence number. Okay. And I mean, this means 1 byte is used in this connection. When finish equals 1, finish is a flag, I'll say tell later. It also take 1 sequence number. Okay. And when 1 data byte will take 1 sequence number. Okay. And okay, so hence acknowledgement flag expects acknowledgement flag tells us what is the next byte it is expected. And since this is taken already 1 byte, it will expect 522 byte number 522. So that's why it will just take 522. This is coming to the receiver, and it will again send a packet. Okay, in this packet, it will send. This is okay. So now the SYN will not be 1. So SYN will be 0 here. But what is the sequence number it will send? The sequence number it will send is 522 because it is expecting 522. It will send the 522. But this will like this will acknowledge this, that I also got your synchronization message. So to acknowledge, since this is acknowledging this one, this will be acknowledging this one. So this will be the then acknowledgement flag here will be 1, and ACK will be 2001. So since this is a SYN packet, so ACK equals to 1 doesn't take any sequence number. Okay, doesn't take any sequence number. But since there is SYN is 1, it will consume 1 sequence number. And here it is expecting 2001 and ACK is 1. So this is how the connection is established. This is called connection establishment or three-way handshake. Okay, so three-way handshake. Once the three-way handshake is done, now you give me your packet where it is written where is India in the map. I'll put my header and I'll start pushing this data to the server and getting my India map back. Once this is finished, I'll close the connection. Okay. This is the whole story, like how this India map is getting back from your server. But just to out of curiosity, if I reply a packet, okay, what if I reply a packet? What will be the sequence number of this? Sorry, what will be the ACK of this? I give the answer. The ACK of this packet, this packet will be 522 itself. Why? Since this is a ACK equals to 1 and there is no SYN flag, it will take 0 byte. since it is taking 0 byte, 522 will be the next, the expected next sequence number for the receiver. Okay. So there are a lot of things that can go wrong while this thing is there. It can be lost in between. Okay. This can be lost in between. This can be lost in between. What can happen is that when you can send this, it will be delayed and you send another packet connection request. And after this reaches here, this one also reaches. Okay, so there are several things that can go wrong while the connection is established. For all cases, there are inventions or there are protocols to follow. You have to see the lecture carefully again because it's a long topic to cover. So I'll not cover that, but you have to see the lecture again to understand what can go wrong and what will be the um, what should be the correct procedure to resolve that thing. Okay. So in the data transfer phase, what you do is that you send one data. Let's say you send by bit of 224, and you said 20 bytes. Then it will expect you to send. So this will be 244. It will expect you to send 245 next. Then you send 245 to 265 and so on. You just send a lot of bytes and you get response and so on. Okay. So connection then comes the TCP connection closure. Connection termination. Okay. In the connection termination, what you do is that connection termination also is 3-phase. You send similarly. If you understand establishment connection, this is fine. You said all my data is done. Okay, so I just need to finish the connection. You said fin flag equals to 1. There is fin flag. I said fin flag is here. So you said fin flag to 1. You send it and it will acknowledge it. Okay, FK equals 1 and said, okay, your connection is done. I'm happy. But I have some data to send, still data to send. It will send all the Google Maps data. And after that, it says that, okay, my data is done. This is my finish request. And this sender will say that, okay, your finish responses, finish request is acknowledged and the connection is finished. So the connection will be terminated between these two. Okay. This is the whole story behind how this, when you are requesting for Google Maps, how it is going and how it is communicating with all these things. And yeah, so let me show you. So what we did is that we have a lab here where there is different devices like there are different devices such as not yeah, so we have different devices, and when you turn on all the devices first, so it will first go through the connection establishment phase, then the data will be transferred. First you say the first you say uh, first you establish the connection. Like, let's say you turn on your Google Home or Amazon Alexa. So first it will make a connection with the outside world, then like an internet, then you can speak to it. Um, Let me see if I can show that to you. Uh,
वो नहीं करवा रही है।
मुझे बता वो लेडी का क्या नाम है?
क्यों?
अरे तुम्हारी लेडी का नहीं पूछा है जो पता नहीं किस चीज में
उनसे नहीं हो रहा है, उनके थ्रू नहीं हो रहा। अरे उनके थ्रू नहीं हो रहा है यार।
हेलो
Hello.
हाँ कट हो गया।
Computer science. Okay, so yeah, so getting loaded. Let me. Okay, so I wanted to show that. Uh, so we have a lot of devices and we capture traffic from the devices, and it's very easy to show that how this three-way handshaking is happening in the YSR. So uh, let me. It is frozen. Not sure. very fast. I cannot. So okay. Share this screen first. How to clear this? Voice is not coming. Yeah, I was not talking. I just yeah. So uh, uh, how to uh, where is that? Hmm. TCP dot flags dot sin source to one. Okay, 285. Sin, where is sin? 285. Okay, let's go to 285. These are all the package that is currently running here. Okay. Okay, you can see. Okay, so here. So this is my computer, and if you open Wireshark, so if you Wireshark is a software. So I'll show you. So Wireshark. So Wireshark is software where you can capture the traffic that is going through your computer. Voice is not coming. Why? So voice is coming actually. Okay, so I'm not on mute. So you can check your computer for if your computer is in mute or something. So can anyone else comment if my voice is coming or not? Yeah, the voice is clear. Okay, fine. So this is Wireshark. This is
11 जणी तो हाँ
yeah. So this is software Wireshark, and you can use this to capture the traffic that is going through in your network. You have a computer, you have your router that is coming,
समझ में नहीं आ रहा सर आ रही आवाज क्लियर
and you can download this and you can see the traffic that is flowing through your computer. Okay. So I wanted to show how that this TCP three-way handshake is going on. If you look at this packet, so these are all the headers. Okay, so this is your TCP header, this is your IP header, this is your Ethernet header, and this is your physical layer header. Okay, so we'll just now look at the TCP header. TCP header, there is source port From this port it is going, this is a destination port. And this is the sequence number. You see, the sequence number, as I said, it is originated by the RISN, or the random initial sequence number generator. But it is showing 0. I said it should not be start with 0. First thing it is starting 0, it is written relative sequence number. For the sake of our understanding, it is always start with a relative sequence number for readability. But the actual sequence number is this. It is a very random sequence number generated online, generated by the sender. So the actual sequence number. What is the next sequence number that is expected? 1. That is again relative sequence number for readability, but actual will be here will be 229. Okay. Acknowledgement number is 0. Okay, if you see, if you have recalled, if you recall your drawing, acknowledgement number is 0. The first thing. Raw is also 0. This is the raw one. Second one, this is the raw one acknowledgement number. Header length is 44 byte. Okay, so header length is 44 byte, and RFDSS. Okay, these are the flags. Header length is 44 bytes. Okay, and there are flags. SYN flag. Okay, so there are other things as well. I will not go into that. Checksum is there. Checksum is like the hash that I discussed in the initial part. Window is 65535. Okay, and they should also mention the calculated window size is the 65535. I said like 14,600. This is 12,535. Flags is yeah. Where is the yeah, so sync packet is present, sync flag is present, and the sync scene is one, and this is your yeah. So they are all the things like basically what I mentioned in the lecture, that this all things are present. Then what is coming? So then it is some other connection, UDP connection. There is also some UDP connection, but if you go to the 288, it is a reply of that. You see the desk. So if I just show it here. So this is the port from 57071 to 433, 443, and this is 443 to 57071. Okay, and here the SYN flag is set. That is the written SYN. Here the SYN flag is set, as well as ACK flag is set. Okay, here the sequence number is 0. Here the sequence number is 0. Because it is the reply flag. Here the acknowledgement number is 1 because it is the acknowledgement. Window size is set is here. Window size is the same is here. MSS is 1460 that I said, and window size is 64. If you multiply the window size with MSS, you will get this number. I can show you now. 1460 times 64. what is 6? 1460 with 64, and this would be no. Maybe this is different. Maybe this is different. Not the same thing. Okay. Maybe this is the maximum segment size, and this is the window size. Maybe the maybe this WS is different, not the window size actually. Okay. Yeah, I'll do that thing later. But yeah, so but everything else is fine. And in the reply, what you do is that you do everything that is there, like MSS here is different. The MSS here is 1460, here is 1436. If you see the notes, so I'll just open the notes for reference. One note. No. I'll open here. One note. Let me go to OneDrive. And one note is the what? Yeah. Yeah. So this is sin equals to 1. Sequence number is 521. MSS 1460. Window size is this. You go here. You see, thing is 1. And sequence number is 0 and this is relative. Window size is there. MSS is the maximum segment size is 1460 here. It is 1460 here. Okay. But in the reply packet, you have to set the acknowledgement flag as 1 as well. So see here, acknowledgement flag is 1. What is the next byte expected? ACK equals 1 because sequence number was 0. And this sync flag takes off onto one sequence number. Okay. So acknowledgement will be 1. What is the next expected byte? And also here sequence equal to 0. Sequence equal to 2000 here. But this is generated. So like it is relative, so it will be 0. Window size is something else. And MSS is MSS is your maximum segment size 1436. So yeah, so the window size. So if you multiply this with your window size or this with your window size, it doesn't have to come with. You will be like so it doesn't have to equal to this because there are some other memory reserved for other things. So yeah, so len equal to 0 and this is this, and you can check it here. So you are expecting it was 521, it is +1. So this is the reply packet. Then you have to look for the third, the request, reply, acknowledgement. This is the third packet on the three-way handshake. We have to search for the third packet of three-way handshake, and it is here. You see, so you can also see the IP address 29 to 49, 49 to 29, then again 29 to 49. And it is going from port same as the first packet 57071 to 443. The scene is 1. Sorry, only acknowledgement flag is set here. You see, only ACK is 1. Scene is 0. That's why there is no scene here. Here is scene, here is scene and acknowledgement. Here is only acknowledgement. And sync is 1. The sequence, so since it is expecting the byte number 1, it is sending the byte number 1. ACK is 1 because it is sync number is 0. So ACK is 1. Window size is this. So every time the window size is advertised something different. Okay. So now the window size is advertised like this, and the three-way handshake is done. Okay. Let me see the next packet that is there. Next packet that is going from 192.168.0.29 to 49. Let me see. Yeah. So yeah, this is the next packet. Next packet is going and see is client hello api.github.com. Then it is going to 49. Where is the next 49? Yes. Yeah, you can see the next packet. The next packet, you are sending a sequence number of 582. That means already 582 byte of data has been transferred between them. Okay. So let me go to the finish part of this connection. TCP dot flags dot fin equals to 1. You see, 29 to 49 should be the connection should be there, like 29 to 49. Source 29, 29, 29, 29, 49. Yeah, here. See this one. This is the finishing thing. So you set finishing flag to 1 and acknowledgement flag to 1. So here see in the finishing fin is 1. So And then this is the 14 to 29 to 49, 49 to 29 again, finishing acknowledgement. So the finishing, this is the finishing thing. Okay. I don't think you will see 29 to 49 after this. 29 to 49. Yeah. So there is 29 to 40. Okay. So there is what is 29 to 49 again. So there is no 29 to 49 again. So here you see there is 29 to 49. But if you see, the port number is different. So that there is a different connection. So here the port number is 57071 to 443. And here 5737 324. There is a different port number that operating with. So there's a different connection. It must have its starting flag and 3 handshake and data transfer phase. And this is the entire thing. Every connection has all these things. All the TCP connection, you will have this. So if you say UDP, if you look at UDP connections from the starting, so there is no handshake. You see, there is no SYN flag or anything. Just UDP flag is just source, destination, data. That's it, nothing else. Okay. So this is all about the thing that I wanted to say and show you. So if you have any doubts, you can ask me now. So yeah, so if you have any doubts, you can ask me now. But most importantly, I'll share the YouTube channel where I'll be uploading the videos. You can subscribe to that and also press the bell icon because it's important for you and important for me as well. I'll get more views and stuff. So I don't actually advertise that, but I'm putting it in the chat and I'm waiting. Everyone should subscribe this and also watch the prior week videos. Here, I will share the video link as well. So please go here and watch it. Even if you don't watch it, you can just keep it open and look for the interesting parts. But yeah, please do watch it. It will be helpful for me. So here is the video of what I post in the YouTube. So do subscribe or do watch it in the past 2 weeks video. But this is my channel. So I'm just staying here. Please subscribe it now, so that I can see the YouTube studio, live. What is this live subscriber count? Uh, uh, there is a live subscriber count, I guess. Okay, so yeah, you can please subscribe. I'll go to the dashboard. I think uh, how to see live subscribers sign into YouTube, real time card on the overview tab, analytics on the overview card. There is no more. Okay. See live count. So are you guys subscribing? I think everyone left. I should have mentioned it later. Yes, sir. Okay. If you have subscribed earlier, that is fine. But I think I wanted to make it 100 tonight. So if you have not subscribed, or like if you have any other accounts, you can please subscribe and make it 100. It will be a big thing for me. So if you enjoy this session and if you think it's a good thing, then you can subscribe. So if you have already subscribed, then it's fine. You can leave the meeting. I think the discussion for today is done. Okay, bye. Someone subscribe. Someone else can subscribe. Okay, so I'll see you guys later, I think. Okay, someone else subscribed. So if you subscribe it to 100. So, okay, if you have subscribed, you can leave. The meeting is done for today. Thank you.